of sine x. So let's graph that. It starts from 0 and it's going to end at 180. So this is called one cycle. One cycle of sine x. And notice there are one maximum and one minimum. So now we know, first of all, we do know from unit circle. Let's go to unit circle. And at this point, we want to use a pen to put in the coordinates of the quadrantal angle. So I just want to start here. Right here, x is 1. Y is, this point is 1, 0. This point is 0, 1. Coordinates. And then this is negative 1, 0. So here x is negative 1, y is 0. And right here, 0, negative 1. Okay, so we just worked on quadrantal angles. Now I want to put the angles in radian. So here I have 0 radian. I also have 2 pi radian. 2 pi radian, remember that 2 pi radian is 360. Here I have pi over 2 radian. That's 90 degrees. Here, this is 180. And I want to write pi here, pi radian. And I go to 270, and that is 3 pi over 2 radian. And so on. So I just got the quadrantal angles there. I'm going to redraw. So I'm going to redraw the unit circle. This is already, this is 2 cycles. So the cycle we have just drawn in our calculator is like this. The one we just drew in our calculator, one cycle. One cycle is the right side. So here we want to talk about the properties of the cycle we drew, the sine x. You want to see, let's go back to that unit circle. We want to see that the highest value for sine is 1 and the lowest value is negative 1. Therefore, the range of sine x is from negative 1 to 1. The range is from negative 1 to 1. And the domain, what are we talking about the domain? Well, suppose I did not put the intervals there. If I just decided to graph sine x in my calculator, it's just going to be, it's going to continue from here to infinity. Okay, so that's why we say it's sinusoidal. So one revolution is this. That's one revolution. And this is 2 revolutions. So 2 cycles. Okay, so we want to make sure we start with the properties of sine. So one thing we know about sine right now is that the highest sine is 1, the lowest is negative 1. We want to draw, let's go back and do it in a better way, the way we are going to, let me go back to my whiteboard and actually go and see if I get another whiteboard or plain whiteboard. All right, I get a plain whiteboard right here. Let me get this one. And this is a circle. Let me make that bigger. I don't want it to look like an ellipse. Okay, I make this one bigger. Looks like a circle. All right, so, and then I want to also draw, I want to make a table. And this table, we already know everything in this table, so that we know that on the left, on the first quadrant, all students all students take calculus. We also do know that here we have plus plus, minus plus. So we're saying that, I'm going to take that off. Okay, so we have minus plus. So x-axis is negative. And right here we have negative, negative, the signs of this in this quadrant. We have a plus negative. Also, we want to look at the graph we just drew before we came here. So I'm going back to my, and then I'm going to look at that. We want to see that whiteboard again. See this one. And we kind of look at this again. We see that each of the sine, let me also get my, so each sine curve that we drew started from the origin. Each sine curve started from the origin. So remember in your Math 110, you talked about symmetry. So sine curve does not have y-axis symmetry. It actually has x-axis symmetry. We have, look at that, you see that we see that maybe we're going to call it origin symmetry. That's origin symmetry right here. Okay, so x, sine x or sine curve does not have y-axis symmetry. Let's do the same thing we did to sine to cosine before we compare. So we're going to do some comparisons and we see what goes on here. So let's see if we can get a cosine curve. So where is that PowerPoint so I can get cosine curve? So I'm just going to go to the PowerPoint that we had and go back to 9.6. And it's already open. So we want to also draw the cosine curve up by ourselves and compare, because I don't want to use the one drawn by, okay, here's the cosine curve drawn by our book. Okay, let's also draw the cosine curve. We want to do some comparisons. Let me put my calculator here. This time we are drawing the cosine curve. So y equal to cos x. So we're going to go to y equals, and I'm going to clear, and I'm going to put cosine there, cosine x. I'm not using theta because it's going to take you time to type in theta there. I use x in place of theta. And then because I already know that the range of cosine is from -1 to 1, and the curve goes to, fluctuates to infinity. So it goes up and down, up and down. It's a wave, sine wave, cosine wave, goes to infinity. So the domain is from -infinity to +infinity. The range is from -1 to 1. What am I saying? See, the maximum here is 1, minimum here is -1. Okay, but let's see our own curve. We see that they drew 2 cycles. I don't want to draw 2 cycles. So let's draw 1 cycle. So let's go back to mode. Before you graph your sine or cosine or cotangent, whatever you're going to draw, if it is a trig function, you must be in radian mode. So make sure that you are in radian mode. So we are in radian mode. Okay, second quit. So I'll go back to my y equals, I typed in cosine of x. I go to Windows, the same window. For cosine, sine from 0 to 2 pi, I already typed in. I want x scale of pi over 4. That's what is here. And I want to use the maximum y from negative, even though I know that the minimum is -1. I want to put -1 to 1.5 here. X scale, y scale is 1. Okay, this time let's graph the sine curve, cosine curve in our calculator. Only one cycle. So I just want to see one cycle of cosine curves. So you see that one cycle of cosine curve, looking at what the book drew for us, it is from this point to that. Okay, and the important thing I want to emphasize in the cosine curve is that the cosine curve is symmetrical to y-axis. In other words, the y-axis divides the cosine curve into two congruent parts. So the cosine curve has y-axis symmetry, and the sine curve does not have y-axis symmetry. Cosine curve has y-axis symmetry because it passes through the vertex. One of the vertices passes through the y-axis. So we want to differentiate. There are things that are opposite or different in sine and cosine. We already have seen one, that if I'm drawing a cosine curve without any transformation, y curve will be symmetric to the y-axis. All right. The range is from -1 to 1. The domain is from -infinity to infinity. Okay, but what do we say that the range is from -1 to 1? So let's go back to this PowerPoint here. So I'm going to take this out. Let's get away from here. All right, so I'm gonna grab you and move you out. Okay, and then I just have to bring back just this one. So I'm just going to bring back the circle here. Just bring it out and make this circle bigger. Okay, well, this time I want to check why is it that they said that the cosine curve, I'll make this thick line, make this line thicker. No, I did not make it thicker, but anyway. So this again, the point here is 1, 0, not big enough, make it big enough. 1, 0, beginning to be bigger. 1, 0, okay. And this point is 0, 1. And this point is -1, 0. So at the quadrant, 0 and 2 pi. So 0 and 2 pi are here. Okay, 0 degrees, 2 pi, radian, because we're graphing. So when you're graphing, you better be in radian. Set your calculator in radian. All right, so now we are at 90. 90 degrees is pi over 2. We are 180 right here, pi. So that is pi. 180 is pi right here. And 3 pi over 2 is 270. Okay, so I'm going to make a table, small table, which I said I would do before. So let me make a table, small table. I can grab this one and get it out too. So let's see. And I still need this to make a table. Okay. So now I want to make a small table for my so let's see. Okay, this is angle. Okay, I'm just going to say this is angle and this is, so angle, it can be degree or radian, but you know we're talking about radian. And then we want to say ratio. We just go ratio here. Okay, so I'm only talking about the angle, not sine. So 0 for cosine. I'm talking about cosine. Okay, cosine. Cosine of 0 degrees is 0. Oh, 1. Cosine of 0 degrees is 1. Any point on a unit circle, any rotating point on a unit circle is cos theta, sin theta. Cos theta, sin theta. Okay, so cosine of 0 degrees is 1. Cosine of 90 degrees is 0. Cosine of 180 degrees, let me take 90 out so that I can put, let me continue working in radian. So I'm going to continue working in radian. So cosine of 90 degrees, pi over 2 is 0 because it's the first coordinate. And this is 180. Cosine of 180 degrees, look at that, it's -1. Cosine of 180 degrees is -1. Cosine of 270 degrees, 270 degrees, I'm just going to clean something out here. I'll clean this out. Clean this one out. All right, so cosine of 270 degrees is, remember we have 3 pi over 2. So 3 pi over 2. Cosine of this angle, let's look at it. It is 0. We're doing some comparisons. And then cosine of 2 pi, 360 degrees. Cosine of 360 degrees is 1 again. Okay, so I just made the table for cosine only, and they're all quadrantal angles. Well, this is cosine. All right, so I just want to make a sketch of, I'm going to make a sketch. So I'm going to get this out. So I'm going to delete that and maybe clean out some things too. So let's make a short sketch, small sketch of only one cycle. But why do I call it one cycle? Just like in sine, if I want to draw one cycle, it's just 360 degrees. Let's make that again. Okay, so one cycle of cosine starts from here, starts from right here. One cycle of cosine starts from here, completes 360 degrees. And this is what I have actually entered here. Okay, so let's make let me try and make, draw a sketch, just draw a sketch by hand. We did by calculator before, but let's draw a sketch by hand. So that way, so I'm going to, I'll click that out, take it out. So make a sketch. I'm just going to draw a line. Okay, just draw a line on my right hand side. Still not, you're not big enough. It's not big enough. But anyway, then I'm going to draw the vertical line. The vertical line. Okay, that's okay. And I want to graph only the right hand side, one revolution or one cycle of cosine. When x is 0, y is 1. So when x is 0, y is 1. Let's make 1 here. X is 0, Y is 1. In other words, cosine of 0 is 1. That's what I'm trying to say. Cosine of 0 is 1. Cosine of 90 pi over 2 is 0. So this is pi over 2 here, and I'm using only quadrantal angles. I'm only using quadrantal angles. So this is 90 pi over 2. And cosine of 90 is 0. And cosine of 180, we already know it is negative 1. Cosine of 180 right here is negative 1, somewhere here. And then cosine of 3 pi over 2, which is 270, is right here. I want you to remember that we are drawing only one cycle. I'm not drawing 2 cycles at a time, just one cycle. So I can better look at it very well and find out all the properties that I need to find. Okay, so cosine of 270 is 0. And cosine of 360, where is my 270? Cosine of 270 is 0, and cosine of 360 is right here, up here. So we look at one cycle of my cosine function. I'm going to draw a curve as smooth as I can. Draw a curve as smooth as I can. All right, so that is one cycle of cosine curve. Remember today we're supposed to do 9.6 and 9.7 as much as we can. We have already talked about some things in 9.3, 9.7, and 9.8. What, by the way, 9.8 is not in our syllabus. So 9.6, 9.7, and then 10.1, 10.2, 10.3, what is in this. And the test is going to be next week, Wednesday. We do it one test a week, and that's why this class is fast. So we have, this is one cycle. If you're told to draw one cycle means just one revolution. We start from 0 and make a cycle, and then we see again that the cosine curve is symmetrical to y-axis, but sine curve is not. So one thing I will see, let's go to practice test 1, not on section 9 points. Let's see section 9 points, because we have to be comparing them to questions given to us. Let's go to practice test. See, okay, I haven't opened it. Let me open it. So practice test 1 or homework 9.6, whichever one. So homework 9.6 is what I'm looking for, so we can see if we can answer questions, because what we're talking about is already in the test. Okay, so in this homework, which is also in the test, so this is homework 9.6. Homework 9.6. It says match the function y equal to sine 3x, even though that sine b, this is the number there is moved from 1 to 3. That is a transformation. The transformation is moving by 3, so it's going to increase by 3. Well, the most important thing is it's still going to have the properties of sine. So the properties of sine I already know is that because sine, suppose it is 3 sine 3x, but x is already 0, then it's going to be 0. Sine of an angle is 0. So I know that that angle cannot, the answer cannot be here, because it's not the behavior of sine rule without reflection. It's not a reflection. So look at this one. That's no reflection, so it cannot be here. So it must be this one, because I know that a sine curve, whether it is transformed or not, it is still going to be it's still going to start from 0 and it's not symmetric to 0. It's not symmetric to y-axis. Okay, the same thing goes here. Match the function y equal to cos 3x with this graph. You already know that cosine curve is symmetric to y-axis. It cannot be this one because it's not a reflection. And it cannot be this one, it's not a reflection. So it has to be this one because this curve, even though it's enlarged, it is symmetric to y-axis. So that's what I've been trying to make sure we know. Okay, so everybody, if you see a transformation, you know it. This one is sine curve transformed 4 units down. So you can actually do number 3. Sine curve transformed 4 units down. So you look for sine curve. It has, if it is symmetrical to y-axis, it's not the sine curve. It's not what you're talking about because there is no reflection. There is no alteration in horizontally. It's a vertical translation that we have. I hope you still remember her transformation. But anyway, we have to apply it. It's algebra 2. We have to apply transformations in graphing. Okay. So let's look at this one. This starts from, we can look at this. First, let's come over here. How many points did it go down? It went down 4 points, so it cannot be this one. This is down too many points. Okay, so this one looks like what I'm looking for. Okay, so at -4, the curve touches the curve touches y-axis. So that is the one I'm looking for. You must know what you're given. You must apply transformation to graph it. Okay, so we will, after some time, we shall be talking about the reciprocal too. Sine and its reciprocal. When we get into reciprocal, it becomes the sine and cosecant, cosine and secant. Okay, so let's go back to PowerPoint quickly. And I want to make sure that we are talking about the major things because really we're just talking about the major things. So here we will be talking about cosine of, first of sine and its reciprocal. Okay, so before we talk about sine and its reciprocal, I'm going to go back to so let's go here. Let's go here. And I'm going to clear the things that I don't need here. So I'm going to clear these. I don't need them. See if I can make this one bigger so that, all right, can tell this all is. Let's make it bigger and see much. So this is our sine curve, the one we started with. But the book drew 2 cycles. That's okay. 2 cycles are good. So I'm now going to talk about the graph of cosecant. So suppose I want to draw the graph of cosecant CSCX, cosecant X. So I want you to be careful that whenever you are drawing the graph of cosecant, by the way, before we go there, let me draw a small unit circle so that you can understand what I'm saying much better. So any point on a unit circle is cos theta sin theta, right? So any point is cos theta sin theta. Let's consider every point to be P. So at this point now we have 1, 0. So sine of 0 is 0. So since sine of 0 is 0, this is the point. Okay, now sine of 90 is 1. Let's see. So sine of 90, at this point we said 0, 1, 0, 1. Okay, stop. Okay, so we are 0, 1. So the second point is sine, and 0, 1, the 1 is sine. Okay, everybody look, this is the point in our graph here. That's 90. And also, instead of going to the point, we already know this is 270, so I'm going to draw a point here. Okay, and then this is negative pi over 2. This I'm good. I know that at that point also sine is 0, and at that point here, okay, at 270 sine is -1. At so we come here and make a point. Make a point here. Okay. In all the points, these at every maximum point, the cosecant curve has a minimum. At every maximum point, the cosecant curve has. All you need to know is how to draw a sine curve. If you can draw a sine curve, because they are reciprocals of each other, if you can draw a sine curve, every maximum point is a minimum because it's a reciprocal. Every minimum point for cosine is a maximum for cosecant. Every minimum point is a maximum for cosecant. Therefore, the red graph is the graph of cosecant. This is the graph. So anytime you're told to graph a cosecant graph, if you have already drawn sine curve, you can draw a sine curve. You can make it dotted line if you want, but instead of drawing a different cosecant, remember you will be told to, there must be a way you'll be told to show that you understand that cosecant is the reciprocal of sine. And so even in graph, the graph of cosecant is wherever it is maximum, cosecant is minimum. Wherever sine is maximum, cosecant is minimum, and so on. So if you can visualize this and can draw, that's all you need to know about. And then what happens? What happens to all these spaces? Why is it not connected? Why? Let's go. Let's find out. Why are the cosecant curve not connected? It's a good question. At every point that sine is 0, cosecant is undefined. What am I trying to say? What am I trying to say? Look, at this point, sine is 0. Sine pi over sine pi 180. Sine 180 is 0. Therefore, cosecant of 180 is 1 over 0. 1 over 0 is undefined. Therefore, actually, I shouldn't continue this. I should, because this is a vertical line, so you draw yourself a vertical line at the point 0. All the places where sine is 0, there is a vertical asymptote. There's a vertical asymptote at x equal to 0 because sine 0 is 0. At negative 180, that's a vertical asymptote. At a negative 360, negative 2 pi. So let's get a calculator then. Let's get a calculator and graph it. How would I use my calculator to graph cosine? If I'm told to graph cosine, how would I use my calculator to graph cosine? This is how I do it. You help yourself more by. So this is cosine here. I'm going to just clear cosine and go back and draw sine again. But I want you to know that this is section 9.7 because we really section 9.6 is sine and cosine. Section 9.7 is reciprocals. And then later on, we shall talk about tangent and cotangent, graphs of, okay, so let's go to, and I'm talking about x. Wherever I see theta, I put x in there, okay? And then this sine of x is 1. So now go to y2, and I will just say 1 divided. I know that cosecant is in my catalog, but that's not what I want to type in here. 1 over, I tell my calculator, vers, y vers, function y1. I tell my calculator to put in the function in y1. That's what I just did. Then I will go back and adjust my windows. So I'm going to adjust my windows, and let me actually make these windows from negative 2 pi to 2 pi. From negative 2 pi, negative 2 pi. Remember that pi is under caret to 2 pi. So I'm going to do 2 pi also. So let's see the figure. Let's see the curves. That's what we say is sinusoidal. It is periodic. Okay, 2 is pi. So I have 2 pi here. I would still like to use pi over 45 as my x scale. But my y scale, I will increase the y scale, because you can see that y scale looks like it's actually gets to infinity. So I'm going to do from negative, let me make it 100 to 100. All right. I'm not bothered about pi in y, because really they are numbers. Okay. And so I can graph and see how this looks. And then I can adjust my window later. But before I graph, I want to go to Windows. Actually, go to mode. You must be in radian mode. When you're drawing a graph of a trig ratio, you must be in radian mode. I know I've said it before, but saying it again wouldn't hurt anybody. Okay, so and then I am going to graph. So I graph, and look at what I have. Hopefully it's going to draw for me. All right, because I don't see it very well, I'm going to make my change my y. So let me do it from negative 5 to 5, because I think it's too small. I mean, it's too big. I want to see a clearer picture, so I'm going to. Okay, so that is sine. All right, this is what I want to see. All right, so notice that every maximum point for sine is the curve shows up. Every minimum, it shows up. So every maximum point for sine cosecant is a minimum. Every minimum point for sine cosecant is a maximum. A maximum means upside down, concave down. I hope you remember, concave down. So cosecant is concave down at every minimum point for sine, and cosecant is a minimum at every maximum point. That's all you need to remember. And another thing you need to remember is that at every x-intercept of sine, there is a vertical asymptote. There is no value for cosecant. Okay, well, let's go to secant. Let's graph the secant. Just like we did sine and cosecant, that's what you do when you're told to graph a cosecant draw a cosecant graph. So you first of all draw, if you're told to draw a secant graph, you first draw the cosine curve, and then on top of it, you draw the secant curve. So let's go ahead and draw a secant curve. And how do we draw secant curve? I'm just going to clear this, and I'll go to y equals, and I put in cosine curve there, cosine x, and I close it. Okay, now that I've done that, my y2 is still going to be 1 over cosine, and y2 is now secant. So y2 is secant, so I'm going to graph both functions. And I want you to know that I started from negative 2 pi to pi. From negative 2 pi to pi, I would like to use the range I use for cosine, the y-axis. Okay, and then I'm going to graph. So the cosine curve is graphing. It is symmetric to y-axis. The secant curve is graphing at every maximum point of a cosine curve. There is secant is a minimum. Same thing. And every minimum point of cosecant curve, a secant curve, look at the cosine curve. So at this point, secant is a maximum. At this point, secant is a maximum. All right. And so notice that you can always graph the line, the equation, or the graph of a cosine curve with its reciprocal. That is the best way to answer the question. Okay, by the way, let's go to homework 9.7 and look at, we are just interested in, okay, so we're already in 9.7. Okay, we're already in 9.7 and I want to answer the question. Find the graph of 5 cosec x. So you ask yourself, this should be the one, but let's go here. It cannot be D. It can't be this is related to tangent and cotangent because sine is not symmetric to y-axis. It cannot be this. Remember, I'm drawing cosecant graph. And so it cannot be this. It has to be this. If you try, you can actually try to graph your cosine curve, sine curve. You can see, you will see that it has this, and so on. And then if you continue, you have that. So you can try and superimpose it. So you cannot fail a question like this because this question is already in the text there, even though if you know it is just a 1 second answer, but you need to know okay. So what other properties do they have? Let's go to the PowerPoint. We want to know what other properties do they have. Okay, what other properties? Then we shall later on graph. Look at this one. Whenever there's something we call amplitude, period, and phase shift. And so we're going to go there later on. But for now, the simple sine and cosine curve is what we are interested in for now. Okay, so these are the sine and cosine. And so I'm going to pull up the PowerPoint 2 also. So where is that PowerPoint 2? I'll get there and pull it up. And I'm talking about PowerPoint 9.7. That's what I mean. PowerPoint 9.7. All right, so now I get all of them so that I can just pick what I need. Okay, so what do we need right here? All right, we have already said that cosine is symmetric to y-axis, and we talked about this already. And if you are told to draw a cosecant curve, you can use your calculator. Even if you don't have to use your calculator actually. If you're given curves, all you need to know is the properties we talked about, and then you will figure out. Okay, and then you figure out the other things that you need. This is the way we drew it. You can be told to draw it that way because you really don't have time in this class. You want to make sure that you use sine to draw cosecant, and you use your cosine to draw secant. That will solve your whole problem. That will make your world easier. So the next one we want to do is talk about tangent. How does a simple tangent curve, how does it look? So, well, let's look at tangent curve. Where did that tangent curve start? Okay, so that started here. Let's look at it quickly. Okay, this is tan 2x, but I just want to start with the one that is just tangent of x. Let's get a calculator. And so I'm going to turn my calculator on. So I'm not drawing the graph of tan 3x. I'm just drawing the graph of tan x. See how it looks. And I want to check from 0 to 180. I mean, 360. But I know that the period of period of tangent is not 2 pi. It's not 2 pi. So we're going to discover that very soon. The period is not 2 pi. So tangent of x, and I'm going to close parentheses, and I want to go to Windows. I can use, I don't want to use 2 pi. Let me use pi, negative pi to pi. That's what I want to use, negative pi to pi. In other words, 2 pi. So second caret, and then 2 pi, caret, and this is still pi over 4, so no problem. I'm going to use negative 2 to 2 in my y. Remember that the mode has to be in radian also. I'm going to go ahead and graph. So what I just drew is the graph of a tangent from negative pi to pi. In other words, one cycle. So one cycle of pi. Why am I having something like this? By the way, why are the graphs broken? In other words, we have only seen two continuous functions here, the sine and the cosine. Sine is a continuous function. In other words, you don't have to lift your hand because before you draw it. Cosine is a continuous function, but secant is not a continuous function. Cosecant is not a continuous function. Tangent is not a continuous function either. Tangent is not a continuous function either. So you want to find out. So where are those broken lines? Where are those broken lines? So we're going to see it. Why? Let's go and find y in a unit circle. Because if we can find y in a unit circle, that is going to solve our problem. So I'm going to get a unit circle and actually look for, I don't need this one anymore. Excuse me, can I call you back, please, if you don't mind? I know. Hello, this is Roxana. Can I call you back, please? I know this is an important call, but I'm in class, I'm teaching.
Oh, okay, Miss Roxana. So I'm not sure that I'm gonna be available, but
okay. Can you call?
It's Xenia from Wells Fargo, from Atlanta.
Oh, I know you. I saw you, but can you please? Can I call you by 2:30 p.m. today? 2:30.
I'm not sure because a lot is full of customers. I get to exit.
Yeah, of course, I know.
I can call you back in my free time, so okay. I'm gonna definitely return. Okay.
I'll pick up. Thank you. Yes, ma'am. I'm in class. I'm sorry.
Okay, I understood you. Thank you. Bye bye.
Thank you. Bye. All right. I apologize to you again, but this call is important. I'm sorry. Okay. All right. So we want to know why the sine curve is broken. Sine curve is not a continuous function. So let's go to a plain whiteboard and find out. Plain whiteboard, we want to find out why sine is a broken function. Okay, I'm just going to get a unit circle, just a circle here. And another thing I do know, we do know that tangent of theta is equal to sine theta over cosine theta. All right. So we also know that this point is 1, 0 on the unit circle. This point is 0, 1 on the unit circle. This point is negative 1, 0 on the unit circle, and this point is 0, negative 1 on a unit circle. Okay, and we already know the angles here. So at this point, I want us to remember that sine is cosine, sine over, tangent is sine over cosine. All right. So wherever cosine is 0, wherever cosine is 0, tangent is undefined. Where? Let's make sure we know them. Let's make sure we know them right now. We need to know them. Wherever sine is 0, wherever cosine, the denominator is 0, tangent is undefined. So let's start from tangent of 0. Tangent of 0 is sine over cosine. Sine over cosine, 0 over 1 is 0 right here. So tan 0 is 0. We want to find out. So tan 0 is 0. So let's go to tan 90, pi over 2. Cosine of 90 is 0. Therefore, tangent of 90 is undefined. If you get this, then you don't have any problem. Okay? All you need is what we are saying. Because really, if you understand this, then you understand cotangent. And if you understand cotangent, you can explain why the vertical asymptotes. And you don't need a calculator to grab them. You can answer all the questions in. Okay, now let's go to 180. Tangent of 180 is 0 over negative 1. This is 180. So 180 is pi. Talking about quadrantal angles. So this is 0 also. And then tangent of 270, 3 pi over 4, 3 pi over 2. Tangent of 270 is 3 pi over 2. And cosine is 0. Cosine of 3 pi over 2, 270 is 0. Therefore, sine divided by 0 is undefined. All right. Tangent of 360, that is 2 pi. Tangent of 360, at 360 is 1, 0. Sine over cosine, so 0 over 1, that is 0. All right. So at this point, tangent has a vertical asymptote. Vertical asymptote, VA. So vertical asymptote. So let's go back to that graph we drew. Let's go back to the graph we drew. So now, why do we see that there's a break here? So this break right here at the right is sine 90, pi over 2. At sine 90, there's a vertical asymptote. At sine 3 pi over 2, there's a vertical asymptote. Sine 0. So now you only have a curve that is this way. All right. Suppose we have, let's make it as a reflection. Suppose I'm told to graph sine of a negative angle. Second insert, I'm going to put a negative there. And then I'm going to graph that. So when I graph that, it's a reflection. The same thing happens. There is a vertical asymptote at 90 degrees, a vertical asymptote at 3 pi over 2. All right. So these easy graphs are the ones you want to make sure you know how to graph. You want to make sure you know how to graph this one. Okay. So let's go to simple trig ratios. And that before we need that to other convert other. And then actually, if you know how to graph, let me go back. I didn't talk about cotangent. All right, so now this is a sines of tangent. Let's go back to the right here. I'm going to make a sketch for cotangent. So let's make it a sketch for cotangent before we skip that. So I'm going to make a sketch for cotangent. I'm just making something like a table of value for cotangent. All right. So now this is cotangent. This is the angles. This is cuts. All I need is to find the reciprocal. What is the reciprocal of when the angle is zero angle here? And if this is cotangent, what is the cotangent of 0? 1 over 0. So whenever the tangent is 0, cotangent is undefined. That's all. That's all you need to know. So sine 90, cotangent of 90 is going to be 1 over 0. See, at this point, this point here, we have 1. See, we'll see cotangent of 0. Let's make sure we look at this one. Here, cotangent of 0 is undefined. So here it's undefined because cotangent is cosine over sine. So wherever sine is 0, cotangent is undefined. That's all we need now. Wherever sine is 0, cotangent is undefined. So cotangent of 0 is undefined. So pi over 2, let's go to pi over 2. And right here, we're not worried about that because it's cotangent of 90 is 0 over 1, which is 0. Cotangent of 180 is cosine over sine, which is undefined also, and so on. Since it is reciprocal of tangent, so that is the major things. These differences are the things we need to know. Okay, and then we will talk about periods later on. We will talk about periods and other things. So let's go back to the PowerPoint. We are switching up and down to make sure that we get the views from the book is good. Also, it is good. So this is for a sine. This is for cotangent. What about, by the way, when you graph the cotangent, it looks like a reciprocal. It looks like a reflection. So everybody look, this is the equation I have here is tangent. And let me clear that. I just want to put tangent of theta and close it. And then I want to graph the cotangent, the reciprocal. So 1 divided by y1. So I'm going to tell my calculator to give me verse, y verse, function y1. Give me the inverse or the reciprocal of the function in y1. So I'm about to graph. Let me check my windows. I think it's okay. And so I'm going to graph. Let's see what happened. What's happened? Oh, okay. I didn't put anything there. All right. I need to put something there. And that is theta. Oh, I don't want to use it. I'm going to use x. Okay. Okay, that's it. And then let's graph it. So this is the graph of cotangent. Well, guess sine. I mean, that's sine. Well, guess what? The cotangent looks like the reciprocal. The cotangent looks like a reflection, but that's cotangent. All right, cotangent. There is a vertical asymptote. The cotangent has a vertical asymptote at 0. If you can figure out where they have vertical asymptote, you can do the graph on your own. You don't need a calculator. You don't need anything. If you can figure out where they are discontinuous functions. If you can find out what makes them discontinuous. Why are they discontinuous? Because wherever sine is 0, cotangent is undefined. And wherever cosine is 0, cotangent is undefined. That's all you need. And then other things you can actually do on your own. Okay, so there are 3 ratios we need to go to and make sure we talk about them. So I need to get a unit circle, and then we need to talk about these 3 ratios. I'm not talking about this one. I'm talking about unit circle, blank unit circle. All right. Okay, so I get a blank unit circle, and we want to make sure we talk about this. And so next class, we shall be actually start solving problems, trig equations. And if we can talk about this, we can solve trig equations. All right, so this is a unit circle, and it is a unit circle, and the hypotenuse is 1, and this is an angle. And if you look at this one, this is 30, this is 45, this is 60, and I don't have to start at 60, but I just want to use 60. But suppose I don't want to use 60, let me not use 60. I just don't want to use any angle. So imagine that I don't know, I may not know this point. So let's call this point P. So call this XY. So this is X, this is Y. Okay, so we want to find this angle. Let's call this angle theta, like we don't know what it is. So let's call it theta. All right. By cosine rule, by SOHCAHTOA, we remember SOHCAHTOA, because most of you did very well. A lot of you made A's, actually 100. That's good. This was easy for some of you. All right. Okay, so SOHCAHTOA, we can't forget that. And we cannot forget special right triangles. There are 2 of them. So this is root 3 opposite to 60. And this is 30. This is 1. This is 2. And it's another special right triangle, 45, 45, 90. If we can remember this in every test, if you can remember SOHCAHTOA, special right triangles, then, because really, you will not be given that in a test. I said, you will not. You will have to remember them though. So this is 45, 45, 90. Okay, and we know that this is 1 square root of 2 as a hypotenuse. Okay, so we are told to find the, by the way, before we continue, we want to make sure we know that by Pythagorean theorem that x squared plus y squared is equal to 1 squared. All right, we already know that. Also, this is Pythagorean theorem. We also know that sine theta is equal to opposite over hypotenuse, y over 1. So since y over 1, which is y sine theta, let's make sure we write it there. I know we already talked about this, but I want to make sure that you can also remember this, whichever way you remember it. So sine theta is always, so we call it sine theta. So wherever I see y, I know it is sine theta. Okay, by this triangle again, we want to find cosine theta. Cosine theta is adjacent over hypotenuse, x over 1, which is the reason why we said that y is always sine theta, x is always cosine theta. That's why. And then tangent of theta is equal to sine over cosine. And if tangent of theta is sine over cosine, let's see here. Tangent of theta is opposite over adjacent, y over x, which is the same as sine theta over cosine theta. All right, so let's go back to that equation 1 by Pythagorean theorem. So let's go back to that equation 1 by Pythagorean theorem. By the way, we call this Pythagorean identities. So we call this Pythagorean identities. So since I know sine theta is equal to y, cosecant theta is 1 over y. If I know sine theta, I know cosine theta. If I know tangent and so on, if I know sine, I know cosecant. If I know cosine, I know secant. If I know tangent, I already know the cotangent, the reciprocals. So what if I just clean these ones? I'll clean these ones. So we go to what is major we want to talk about. So we want to talk about this. We need to be, okay. So this is already in our tests. I need to start talking about it on time. So we already said that cosine theta is x. So here we said cosine squared x. Because cosine theta, we found out it is x. Therefore, this point here is cos theta, sine theta. Any point on a unit circle is. So we cos squared theta plus sine squared theta is equal to 1. So we call it Pythagorean identity. We can call it number 1, but it's not even number 1. Because we already know that sine, cosine, tangent, we already know them. We know the reciprocal functions. We can call them, there are 6 trig ratios. Well, this is a major identity that we cannot forget. We cannot forget that. Okay, so I can always find, let's talk about this, then we start talking about other identities. I can solve this identity, or I can rewrite it as sine squared theta plus cosine squared theta is equal to 1. And anytime I can say that sine squared theta is equal to 1 minus cosine squared theta. And if I'm told to solve for sine, I can say sine theta is equal to plus or minus square root of 1 minus cosine squared theta. All right. Okay, so we can use this to solve a problem very soon. Whenever I'm told to find sine theta when we are solving trig ratios, I can use that. Okay. All right, so we can also, let me clear the right part, right side. I'm going to clear the right side because actually I don't need them anymore for now. All right, so I can also say from this one right here, identity number 1, if you want to call it 1, but it's not 1 though. We can say, since I can rewrite as cosine squared theta is equal to 1 minus sine squared theta. Knowing how to rewrite them and solving for cosine will help you solve some problems. Suppose I want to find only cosine of theta in a question. Suppose a question asks me to find only cosine theta. Then that is equal to plus or minus square root of 1 minus sine squared theta. All right, so as we come, let's go to, so we know this already. I'm going to clear everything. Now we know sine theta and we can write it in so many different ways. So I'm going to clear a lot of things. I'm going to clear this one also. And we find other identities. And all these ones we have found square root of the different identities, which you already have seen. You have already seen them in formula sheet. So if you know how to derive them, that way you will actually recognize them when you're asked to find them. Okay, suppose I decide to divide. Suppose I decide to divide all through by cosine squared theta. So I divide this by cosine squared theta, divide by cosine squared theta, squared theta here, divide 1 by cosine squared theta. What do I have? I have that this cancels. Sine squared theta over cosine squared theta, I have 1 here, plus tangent squared theta, tan squared theta. 1 over cosine squared theta is sec squared theta. So this is another identity. Well, guess what? The mother of all these identities are the Pythagorean unit circle Pythagorean identity. This is the unit circle Pythagorean identity, the first one. And then others. Okay, so this is another beautiful identity which you will be using very soon when we start solving equations. Also, suppose I decide, I'm going to clear all of them because now suppose I still remember that major sign, unit circle identity, or you can call it Pythagorean identity. Suppose I still write sine square theta plus cosine square theta to 1. And I decide to divide both sides by sine square theta. Divide both sides by sine square theta, which means you're dividing both fronts. Okay, so sine square theta divides sine square theta is 1. We bring 1 down, plus cosine square theta over sine square theta is cotangent. Cotangent square theta. 1 over sine square theta is cosec theta. Therefore, this beautiful identity we shall be using very soon. We shall be using this beautiful identity very soon to solve problems. So we actually will be solving problems in identities next class, but we want to make sure we derive the identities, the formulas we need, and we know how to derive them. Even though we were given a formula sheet, we will still know how to derive them one way or the other. Okay. All right. So I know that sine theta is equal to 1 over cosec theta. And we know you can divide all those two, but there is one called double angle identity, and on this one, double angle identity, let me pull up before, let me pull up the formula sheet so you know what we're talking about. And then you sum of two identities, difference of two identities. Let me go there and make sure that you know what I'm talking about. So let's go to trig identities. I put it in, okay. And then I want to make it big. And I want to show you what we have already talked about. We want to talk about them even though they are in the, okay, just know we have talked about all this. We have talked about all this. We have talked about this sine, the quotient identities, cotangent and tangent. We have talked about sine and cosine and their relationship with symmetry. Okay. And we talked about cofunctions identity. I'm going to quickly talk about negative angles. All right. we want to talk about double angle identity, but not now. Before we talk about double angle identity, I want us to talk about make sure we know what is the sum and difference identity. Even though it is the last one here, sum and difference identity is the last one here, but it is very, very important. If you know the sum and difference identity, you can actually derive double angle identity by yourself. So let's go to sum and difference and use it to solve a problem. Try and use it to solve a problem. Okay, so I'm going to get blank. So we want to talk about sum and difference identity. It is something you want to kind of memorize, know it somehow, even though you have want to know how to derive it. Okay, suppose I have, make this as what is, okay, anyway, let me, suppose I have sine A plus B. I can rewrite sine A plus B. That is sum of two identities. Come on, clear. Yeah, okay. Sum and difference identities. That's what I'm talking about. Stop. All right. So if I have sine A plus B, I can write it sine A, sine B, sine A cos B, sorry. Okay, so I have sine A plus B. So I'm going to have sine A cos B plus sine B cos A. Sine of the first one, cosine of the second one, plus sine of the second one, cosine. This is a formula. Call it whatever you want to call it. And because it is sine, plus is here. What about sine A minus B? Sine A minus B, this is called sum and difference identity. Then I have sine A cos B minus, note that minus is here, minus is also here. And then we have sine B cos A. Note that they're not the same because it's switched off. Okay, well, this is about sine. Sum and difference identity for sine is that. So let's go to sum and difference identities for cosine. Sum and difference identities for cosine. How do we write it? Sum and difference identities for cosine. This you must make sure you are paying attention. Okay, cosine of A plus B is equal to cos A cos B minus sine A sine B. Everybody look, I want to emphasize this so that you will know. Don't forget that when it is plus for cosine, it is minus here. It's very important. Okay. Now, if I have cosine of A minus B, then I will have cosine of A cos B plus. So when it is minus here, it is plus here. Plus sine of A, sine of A, sine of B. Okay. Well, what if this is called a sum and difference? Now, when do we talk about double angle? Okay, double angle. So let's talk about double angle. And there are so many equations that come out of double angle, but you need to know this one first. And so we're going to pull this up. So double angle identity. Double angle identity. What does that mean? Angle identity. Okay, and that means sine A plus A again. Sine A plus A is sine A cos A plus sine A cos A, which is the same as 2 sine A cos A. So very soon you will be given an equation and you are given sine. This is exactly the same thing as sine 2A. So anytime you are told given sine 2A and you're told to show, then all you need to do is double angle identity. Okay, so sine 2A is the same as 2 sine A cos B. Okay, well, what about subtraction? You can't, let's look at that actually. Sine A minus A is like as good as nothing, sine 0. So there is nothing, you know, there's nothing, no identity there. So let's go to cosine. Let's go to cosine. Double angle identity for cosine. Okay, so come on. Double angle identity for cosine. All right, cosine. All right, so now cosine A plus A, or I can say cos 2A, is equal to, remember, I start with cos A minus, because it is cosine, when it is plus, it becomes minus here, sine A. So you can rewrite, you can say that cos 2A is actually cos squared. See, I can write cos squared A here, right? Minus sine squared A. I can do that. All right. So everybody now you can see that I can decide to rewrite this one. So take away, subtract cos squared A on both sides. Subtract cos squared A on both sides. This goes, and I now have I now have, let me move this up a little bit so that me move it up. So on the left hand side, I have cos 2A minus cosine